Scenario 1. Separation anxiety. Tom, an unloading operator, unloaded a tank truck of 50% caustic soda. Then, he applied air pressure to the hose to clear it of any remaining caustic soda solution. As pressure built in the hose, it separated from the coupling, and the remaining caustic soda sprayed him. Tom's first instinct was to turn away from the spray and shut his eyes tightly. His body was protected by his PPE, but since he was only wearing safety glasses and not goggles, his eyes were not fully protected. This time, Tom was extremely lucky, and the caustic soda did not contact his eyes. But this was a very close call. Tom was also fortunate because a co-worker was nearby and helped him to a safety shower, so he only experienced a small burn behind his ear. Let's review some of the issues at play here. After each question, your facilitator may pause the DVD and discuss your answers with you before proceeding. What was the employee's first reaction to the spraying caustic soda? Tom reacted the way most people would, by turning away from the spray. But by doing this, Tom risked getting caustic soda in his eyes through the open sides of his safety glasses. He was fortunate that none of the caustic soda got in his eyes, and that a co-worker was nearby to guide him to the safety shower. Is it likely that Tom would have made it to the safety shower or eye wash fountain alone before suffering eye damage? Probably not. It would have been very difficult for him to find the nearest safety shower, and even more difficult to properly wash the affected areas without assistance. In this case, the co-worker helped save Tom from potentially serious harm. What personal protective equipment should Tom have worn for this job? Proper fitting, chemical-resistant safety goggles, and face shield are critical when performing this type of task. Wearing goggles would have made it possible for Tom to find the nearest shower and eye wash fountain without assistance and further minimize his risk. Here are some best practice tips to avoid separation anxiety. Always be familiar with your work area. Know the location of all safety showers, eye wash fountains, radios, intercoms, etc. Wear chemical-resistant clothing, goggles, and a face shield when working with caustic soda. Understand how to properly use and depressurize chemical hoses. Remember, safety first. Not an option. In this scenario, a plant supervisor was completing a housekeeping sweep in the plant when he noticed a worker painting handrails in the caustic area. The painter had goggles hanging around her neck. The supervisor informed the painter of the company's policy requiring that goggles be worn at all times in the production area. The painter complained that the goggles kept fogging up and make it difficult to see her work. The supervisor took the painter to the control room and helped her clean the goggles with anti-fog solution. He also explained the necessity of wearing goggles at all times and the severity of a potential eye injury that could result from caustic soda exposure. The supervisor also reminded the painter that the goggles should not be removed, even for a brief period, to clean them while in the production area. The painter wasn't particularly happy about having to wear the goggles due to the fogging. However, the anti-fogging solution did help somewhat, and after the discussion with the supervisor, she understood the reason behind wearing goggles. This scenario demonstrates great leadership by example. His intervention promotes a safety culture within a company's operation, thereby preventing personal injuries. If the painter hadn't immediately complied with the goggles requirement, the supervisor would have immediately removed her from the job site. In addition, let's review some of the other important factors involved in this scenario. After each question, your facilitator may pause the DVD and discuss your answers with you before proceeding. When and where are safety goggles necessary? Goggles are necessary at all times when working in an area where caustic soda is present, or with any equipment that contains caustic soda. Signage should be used to designate areas where chemical worker goggles are required around caustic soda handling areas. What type of safety goggles should be worn when working around caustic soda? Close-fitting, chemical worker safety goggles should be worn at all times. What is the best way to handle goggles that fog up? Unfortunately, there is no way to keep goggles from fogging up in certain conditions. Anti-fog cleaner works well for some, but not others. Remember, goggles should not be removed for cleaning in potential exposure areas. Here are some best practices to help you avoid similar situations. The supervisor did the right thing in intervening in this situation and removing the painter from the potential exposure area to a place where the goggles could safely be removed and cleaned. He also did well to explain the importance of wearing goggles. It is also important to educate workers who are only periodic visitors to your site, such as painters, about your safety policies before they enter your site and begin work. Those that do not comply with your safety procedures and policies should be removed from the job site. Buy the best goggles available. Set up safe stations nearby where workers can go to clean or change to a new pair of goggles without fear of exposure to caustic soda. Rotating pairs of goggles is often an effective tactic. Not wearing goggles in a caustic soda area is not an option. False security. In this scenario, we will see that even people who have significant caustic handling experience should be trained and retrained periodically to avoid accidental exposure and potentially severe injuries, as well as the location of safety showers and eye baths and other safety procedures. John had been working with caustic soda for nearly 20 years. John used most of the proper personal protective equipment, but only protected his face and eyes with a face shield. But what could go wrong? He's done this for years. John turned on a water hose to allow water to run in the spill containment area during the unloading procedure. This particular hose is normally used for tasks such as washing off equipment or washing down a spill in the unloading area. John believed this to be a clean source of water. What John didn't realize was that there was a cross-tie connection between the caustic soda offloading line and the water line. On his previous deliveries, the cross-tie valve had always been closed. On this day, however, it was partially open. John continued his routine, hooking up the unloading lines and beginning to unload his tank truck. Then he stepped back and looked around. Everything seemed normal. However, when connecting the lines, John unknowingly got a small amount of 50% caustic soda solution on his glove. He raised his arm to put up his face shield, and he brushed against his lips. Since the mouth and lips are sensitive mucous membrane tissues, they began to sting immediately upon contact with the caustic soda. John looked at his gloves and instantly realized what happened. While John was familiar with the area and knew a safety shower was nearby, he had never used it, nor even checked it. So, he quickly turned to what he thought was a clean source of water from the hose. But remember that open cross-tie connection? As the caustic soda was being unloaded from the tank truck, a siphon effect in the water caused the caustic soda to mix with water. What John believed to be clean water flowing out at his feet was approximately 10% caustic soda. John took 2 handfuls of water from the hose and threw it on his face. Not only did John get more caustic soda on his lips and mouth, but since he had raised his face shield and was not wearing goggles, he exposed his entire face and got caustic soda in his eyes. In all the years that John had worked with caustic soda, he had never paid attention to that cross-tie connection. He also was not wearing goggles. In the actual incident this scenario is based on, John lost his sight permanently as a result of this incident, as the damage to his eyes was irreparable. This one single incident, as you can imagine, changed John's life forever. Let's review the many issues contributing to this scenario. After each question, your facilitator should pause the DVD and discuss your answers with you before proceeding. What source of water should have been John's choice for washing the caustic from his face? Safety showers and eye wash fountains are the only dedicated water sources you should use. What personal protective equipment would have helped John minimize this injury? While raising his face shield subjected John's face to injury, had he been wearing goggles, he would have prevented irreversible damage to his eyes. Why should you check safety showers and eye wash fountains before beginning a job? It's important to check both the safety shower and eye wash fountain beforehand to make sure you know where they are, ensure that they work, and to make sure the water is clean and not too hot or too cold. Here are some best practice tips drawn from this injury to help you avoid similar situations. The tank truck unloading operator should wear the same PPE and obey the safety precautions discussed in the previous modules of this DVD, or those of the customer, whichever are more stringent. Follow procedures as if you are doing the task for the first time, even if it is something you have done for as long as 20 years. When doing routine tasks, never assume everything is still the same as it was the last time you completed the task. Be familiar with all your surroundings. If others are available, ask questions about any changes that may have occurred since the last time you performed the task. Be prepared for the unexpected at all times. If you are working alone, understand that you are responsible for your safety. Remember, there are no shortcuts. Only skin deep. Javier was walking under some piping in a plant when he felt a drop on his shoulder. He assumed the drip he felt on his shoulder was water condensation on the pipe and didn't realize the caustic pipe above him was leaking. At the end of his shift, Javier started to change his shirt, but realized it was not water that had dropped on his shoulder. When Javier finally pulled his shirt off, he noticed a dark red spot where the exposure to caustic happened. Let's review some of the issues involved in this scenario. After each question, your facilitator should pause the DVD and discuss your answers with you before proceeding. How do you tell the difference between caustic soda and water? Water and caustic soda look the same. All liquid pools, puddles, and drips must be treated as if they are caustic soda solution. Does caustic soda burn skin upon contact? Immediate pain is common when sensitive areas such as your eyes or mouth are exposed to caustic soda. However, skin is less sensitive and exposure will not necessarily result in immediate pain. How deep will caustic soda burn the skin if allowed to go unchecked? Caustic soda will continue to burn until it is effectively neutralized. What treatment should be used for caustic soda exposure? In a word, water, and lots of it. Immediately rinsing with water is the most effective initial treatment to minimize injuries caused by exposure to caustic soda. Only medically trained personnel should prescribe or supervise other first aid for exposure to caustic soda. Here's a best practice tip drawn from this injury to help you avoid similar situations. All liquid pools, puddles, and drips must be treated as if they are caustic soda solution. Avoid kneeling, leaning, or lying on or against piping or equipment at all times. Use a barrier, such as plastic sheeting or plywood, when you must come in contact with surfaces or structures in caustic service. And remember, even perspiration can cause a reaction to surfaces that may have dry residue of caustic soda. Frozen mindset. Frank is an experienced operator. He has been working with caustic for over 10 years, and many times in cold weather. On a cold day, a load was coming in that had been sitting in the rail yard. After hooking up all the connections, Frank opened the internal and external valves. The caustic soda did not flow. The caustic soda surrounding the internal valve near the bottom outlet valve had frozen. A colleague asked Frank if he needed any help. Frank stated he knew how to handle this situation. The rail car's internal valve was open, and Frank removed the external valve with a wrench. But because the caustic soda was frozen, nothing came out. So Frank took a steam lance and inserted it into the caustic soda. Frank heated the caustic soda around the bottom outlet until it was warm enough to flow. Then he removed the steam lance. It was too late. With the caustic now thawed and the internal valve still open, the caustic soda started to run out of the rail car. Since Frank was not in full personal protective equipment, he could not do anything to stop the flow. He ran to the top of the rail car to close the internal valve, but it was too late. Fortunately, no one was injured. The load was contained within a diked area. It could have been much worse. Let's review some of the issues at play here. After each question, your facilitator should pause the DVD and discuss your answers with you before proceeding. At what temperature does 50% caustic soda solution freeze? 50% caustic soda solution freezes at about 57 degrees Fahrenheit, or 14 degrees Celsius. This means that at ambient conditions in many parts of North America, the solution will be thick and viscous, even frozen, during fall, winter, and spring. What should the driver have done to thaw the caustic soda and valves? Low-pressure steam could have been applied externally to the valve area of the rail car. This may have taken longer to thaw the caustic soda, but would have been much safer, and in the long run, it would have saved both time and money. What system minimized the severity of this incident? The dike in the unloading area collected the caustic soda. Here are some best practices to help you avoid similar situations. Never assume things will go exactly the same way they did before. Be extremely cautious when approaching situations that don't seem normal. Seek advice or help when confronted with circumstances that may benefit from the attention of another set of eyes. Never assume mechanical devices are completely safe. Valves should always be handled carefully. Always follow procedures and make notes for others who may perform similar tasks to let them know what could happen. Always wear the proper personal protective equipment when working with caustic soda. Develop the mindset that nothing should ever be considered routine. Unintentional traps. Bill was walking through the plant and saw a hose lying in the walkway. To help keep the plant clean and eliminate a tripping hazard, Bill picked up the hose and threw it over his shoulder to carry it to a nearby hose rack. As Bill did this, caustic soda splashed out of the hose and over his back. It never occurred to Bill that caustic soda could be in the hose when he threw it over his shoulder. Fortunately, Bill was familiar with the area and the chemicals handled there. He also knew the exact location of the nearest safety shower. He was able to go directly to the shower and rinse away the caustic, avoiding permanent injury. An incident review determined that Bill was a victim of an unintentional trap. When questioned, location employees said things like, "The hose should not have been left out." "The hose should have been washed out after use." Let's review some of the issues at play here. After each question, your facilitator should pause the DVD and discuss your answers with you before proceeding. First, what traps are you setting unintentionally in your work area? Do you completely wash off your rubber gloves, slicker suit, face shield, and other equipment every time you finish a job involving caustic soda? If not, you could track caustic soda in the carpet, wipe your gloves on a handrail, brush up against the building, or leave a trace in any number of places where someone can come in contact with it. Second, where are the safety showers and eye wash fountains in the areas you frequent? Do you know where they are and how they work? Be sure the safety showers and eye wash fountains work and the water flow is clean and the appropriate temperature. You're betting the quality of your life on it. Third, do your housekeeping habits protect others from injury? Are all hoses sufficiently washed out, hung up, and dried? Are small pools of caustic soda neutralized and disposed of appropriately? Are leaking pump seals replaced and dried caustic neutralized and disposed of appropriately. Always double check to make sure. Here's a best practice tip to help avoid unintentional traps. When working with caustic soda, think of all your equipment as being contaminated and in need of proper cleaning. Use proper storage and labeling to prevent contaminated equipment from being inadvertently stored with ready-for-service tools and equipment. Avoid traps by always following safety procedures. With proper care, procedures, and protective equipment, caustic soda can be handled safely. It is our hope that this DVD will serve as a useful tool to help you develop your own caustic soda stewardship program. It is designed to help you put procedures in place to ensure the safe and responsible handling and use of caustic soda at your facilities. All other priorities, while recognized as important, are secondary to personal safety. A safe working environment enables us to go home each day uninjured. Real-life scenarios. Now that you've reviewed the training modules that demonstrate how to handle caustic soda safely, it's important to emphasize why appropriate precautions must be followed. The following are reenactments of real incidents involving accidental exposure and subsequent injuries from caustic soda mishandling. While some of these images may be disturbing, after reviewing these incidents, we believe that you will have a better appreciation for why this training DVD was created, the seriousness of injury prevention, and the consequences of unsafe behaviors. While caustic soda brings many benefits to society, it's also a highly corrosive material. Special care and precautions must be taken when handling caustic soda to avoid personal injury. At Dow, we take personal safety very seriously and work hard to ensure that our products are manufactured, stored, transported, used, disposed of, and recycled in a manner that shows high regard for human health, safety, and environmental stewardship. As part of our deep commitment to caustic soda safety, product stewardship, and the personal safety of our employees and customers' employees, we've developed this training DVD. It is organized into several easy-to-navigate modules that discuss developing a safety culture designed for managers, chemical and physical properties of caustic soda, safety procedures and equipment, first aid and emergency response, unloading guidance for rail cars and tank trucks, and 6 real-life scenarios that reinforce the safety message. With proper care, procedures, and protective equipment, caustic soda can be handled safely. This DVD guide can serve as a useful tool to help you develop your own caustic soda stewardship program. It is designed to help you put procedures in place to ensure the safe and responsible handling and use of caustic soda at your facilities. In addition, it is highly recommended that you thoroughly train your employees regarding the safe handling of caustic soda before starting any work involving this material. Carefully develop, implement, and enforce safety procedures. Refer to the most recent material safety data sheet for caustic soda to ensure that your safety procedures are relevant and current. You should have received a copy of the handbook along with this video. To obtain additional copies, please visit our website at www.dow.com/caustic soda. Workplace safety. It's the most important consideration in everything we do at Dow, and we know it's just as important to you. Workplace safety is essential to our families, friends, and colleagues. It helps attract and retain talented and qualified employees, and a reputation for safety also enhances your company's image in the eyes of your customers and in the communities where you operate. But most importantly, a safe working environment enables us to go home each day uninjured, ready to continue our work the next. All of these are great reasons for driving a commitment to safety at your operations. While an important raw material in a wide range of valuable products, caustic soda is a corrosive chemical that, if mishandled, can cause injuries. Workers must be thoroughly trained to avoid hazards when working with caustic soda. Two of the primary reasons workers get injured from caustic soda are that they do not understand the risks and they simply make human errors. Both can be managed with proper training and safety procedures and equipment. Establishing a safety-first culture is the most important step in creating a safe operating environment. At Dow, we set clear expectations about safety in the workplace, and our managers lead by example. Leaders play a pivotal role in establishing and maintaining our safety focus. At the highest levels of our company's management, we communicate clearly and frequently about the importance of safe operations. We apply appropriate rewards and reinforcements for safe behaviors, actions, and results. In the Dow culture, it is clearly understood by our management and our employees that safety is our number one priority. All other priorities, while recognized as important, are secondary to personal safety. How can you establish a safety culture at your company? Reviewing materials like the modules in this DVD is a great place to start. These materials, when used in conjunction with a safety culture, can help you put procedures in place that guide your organization in the safe handling and use of caustic soda. Keys to an effective safety culture include commit, communicate, commend. Following these 3 C's can help establish a safety-focused mindset at all levels of your company. Commitment begins at the top. To create a safety culture, top management must not only be committed to a safety culture, they must lead by example. Many people are naturally resistant to or suspicious of change. So if they see that management is dedicated to a safety culture, they will accept procedural changes more easily. Communicate specific goals and clearly define roles at each level of the company. People are more apt to embrace new safety procedures if they understand why and how their actions will impact employee safety and the company's goals. Track performance versus those goals, since we don't improve what we don't measure. Be sure to communicate with employees frequently and clearly. For example, in 2005, Dow established many goals, including these safety measurables, to reach by 2015. It began with a leadership attitude and corporate culture that is committed to 0 accidents, 0 injuries, and 0 excuses. Thanks to the buy-in and dedication at all levels, Dow is making amazing progress. And this success is continuing because the results are communicated and encouraged. With this effort, Dow's injury and illness rate continues to improve. The goal for 2015 is 0.12. To put this in context, a work group of 30 people would have to work injury-free for 27 years. That's 27 years without a serious chemical exposure, stitches, or broken bones. There's another vital aspect of communication. It must be a two-way street. A viable safety culture fosters input from every level. In addition to a management and down distribution of information, all employees should be encouraged to provide feedback to management for enhancing the safety culture and safety performance. And finally, commend and celebrate successes. Distribute progress reports and reinforce safe behavior by publicly acknowledging a group, individual, or idea. Rewarding safe behavior and recognizing safety milestones are great ways to sustain the safety culture. As a business leader, a safety culture begins with you. Visibly set a good example and make this ongoing. Don't ever let safety slide from being your first priority. Clearly define expectations and continually enforce safety procedures. By recognizing and rewarding good performance, your company will realize its goal of a safety culture. Your company's actions help ensure employees are giving safety the attention it deserves and are taking their actions seriously every minute of every day. We want all employees to go home at the end of each shift uninjured. We're sure your goals are the same for your employees. That's why it's imperative that you share this DVD with your employees who handle or work near caustic soda. The DVD is structured in modules and covers chemical and physical properties of caustic soda, safety procedures and equipment, first aid and emergency response, unloading procedures for tank trucks, unloading procedures for rail cars, spill cleanup, and 6 real-life scenarios. Thank you for reviewing this DVD, and be sure to visit www.dow.com/caustic soda. Let us know if Dow can be of further assistance. Introduction to caustic soda. Caustic soda is one of the world's most widely used industrial chemicals. However, it is highly corrosive, and all personnel handling caustic soda must know and follow strict procedures for safety. Caustic soda is highly corrosive. It can cause burns to the eyes and skin within seconds. To avoid this risk, it is imperative to have proper training in the safe handling of caustic soda. Also, proper personal protective equipment should always be worn. Before starting work with caustic soda, it is important to understand its properties so that you can make informed decisions and take the appropriate actions to ensure its safe use. Caustic soda from Dow is shipped as an aqueous solution. The freezing point of caustic soda varies with concentration. A 50% solution will freeze at about 57 degrees Fahrenheit. Because of its freezing point, 50% solution is shipped and stored hot. Consideration must therefore be given to both the corrosivity and thermal properties of the caustic when defining safe operating procedures. Appearances can be deceiving. While caustic soda has a water-like appearance, it is approximately 1.5 times heavier than water. This should be taken into account when moving containers of caustic, for instance. Because it is heavier than water, caustic soda has a tendency to layer if not stirred. Not taking this into account can result in quality concerns or unexpected reactivity by charging too much or too little caustic into a reaction vessel. To minimize the potential for exposure when diluting caustic soda, the caustic soda should be added slowly and cautiously to lukewarm water while stirring constantly. If caustic soda becomes concentrated in one area, is added to water too rapidly, or is added to hot or cold water, a rapid temperature increase can result in dangerous mists, boiling, or spattering. This could cause a violent eruption and potentially an exposure to caustic soda. Never add water to caustic soda. Always add caustic soda to lukewarm water to avoid potential exposures. There are other situations that may create potential exposures or unplanned reactive chemical incidents with caustic soda which should be avoided. For instance, caustic soda reacts with metals such as aluminum, brass, tin, and zinc. Flammable hydrogen may be generated from contact with such metals. Therefore, care should be taken when choosing materials of construction. Caustic soda may react violently in the presence of chemicals like hydrochloric acid. Avoid unintentional mixing of caustic soda with strong acids. Caustic soda solutions react readily with various reducing sugars such as fructose, galactose, maltose, and dry whey solids to produce carbon monoxide. It is important to consider all potential reactive chemical situations to prevent unintended consequences. The Material Safety Data Sheet provides information on other incompatible materials or product hazards. It should be readily available in the workplace and a valued reference document to understand the hazards of caustic soda solution. Caustic soda is highly corrosive. However, with proper understanding of its properties and operational procedures, it can be handled safely. Caustic soda is corrosive to human skin and eyes. Even brief contact with caustic soda will cause severe burns. Do not depend on leather, such as shoes, for protection against caustic soda exposure. To minimize the risk of caustic soda contact with skin or eyes, all personnel handling caustic soda must always wear proper personal protective equipment, commonly known as PPE. Every task should be carefully assessed to determine what PPE is appropriate. Personnel working with or near caustic soda should wear close-fitting, chemical-resistant safety goggles and rubber gloves. Additional clothing and equipment may be required depending on facility-specific procedures. Other protective clothing may include hard hat, full face shield, plastic-coated or rubber apron, or suit with jacket buttoned up to the neck, and pant legs worn outside steel-toed rubber boots. The sleeves should be sealed at the rubber gloves. A dedicated safety shower and eye wash fountain should be located at or near all unloading sites and use points. Access to this critical safety equipment should be unobstructed at all times. Skin and eyes could be exposed simultaneously, so eye wash fountains should be located directly underneath the safety shower. The water supply for this safety equipment should be isolated from all other processed water. The eye wash fountain and shower should have a large volume, low pressure, and tempered water supply with manual shutoffs. Make certain the eye wash fountain has sufficient flow while the safety shower is operating. Safety showers and eye wash fountains should be tested frequently, especially before each unloading operation. It is recommended that an alarm device be installed at the safety shower so that it can be activated to summon help if the safety shower or eye wash fountain becomes necessary. Why is the safety and personal protective equipment so important? Even brief skin or eye contact with caustic soda can cause serious burns, even blindness. The following photographs were based on laboratory experiments and demonstrate how caustic soda can damage an eye. We recognize that these photographs may be disturbing, and we assure you that no person or animal was injured to obtain them. However, it's important to fully understand the potential severity of consequences that caustic soda exposure can have on eyes and skin. The eye on the left was exposed to caustic soda, but was immediately flushed with plenty of flowing water. Water won't prevent initial damage, but in most cases it will minimize further damage. If the eye was not immediately flushed, here is what could happen. After 7 to 10 seconds, damage would be clearly evident. In this demonstration, you are looking at an eye from a deer. A droplet of caustic is added, and almost immediately the damage is noticeable. Caustic soda can actually dissolve the cornea and attack the inner structure of the eye. The eyeball tissue swells and eventually bursts, causing total and irreversible blindness. The best way to avoid injury is to avoid contact. If contact happens, follow first aid treatment procedures as discussed in Module 4 and as noted on the MSDS. First aid treatment. If a caustic soda exposure incident occurs, it is extremely important that all workers understand the appropriate first aid response procedures. In addition to training employees, you may wish to hold periodic drills to ensure everyone knows what to do in case of an exposure. First aid treatment can be summarized in 2 words: speed and water. Exposed areas should be flushed with lots of water immediately. Rinsing with water is the only acceptable method to remove caustic soda from eyes and skin. Do not use soap, and do not attempt to neutralize the caustic soda with chemicals. Get into a safety shower as quickly as possible. Do not remove goggles unless the eyes have been exposed to caustic soda. Keeping goggles on will help prevent caustic soda from being washed into the eyes. Remove clothing as soon as possible while continuing to shower. Continue rinsing with flowing water for at least 30 minutes or until otherwise advised by medical personnel. A coworker should summon medical personnel immediately. Ensure that first aid responders pay attention to self-protection and use recommended protective equipment. Make sure all hands are clean and not contaminated with caustic soda before touching the face and eyes. Hold the eyes open while continuing to flush with plenty of flowing water for at least 30 minutes. Transport the victim to a medical facility. If caustic soda is accidentally swallowed, drink large quantities of water or milk if available. Contact medical personnel at once. Do not induce vomiting. If mists of caustic soda are inhaled, remove the victim from the contaminated area to fresh air immediately and summon medical personnel. Always initiate first aid even if contact is only suspected, as caustic soda burns may not hurt at first contact. In fact, they may be only slightly irritating. Caustic soda may not cause immediate pain, but it will cause immediate injury. Remember, what you do in the first few seconds is far more important than anything anyone else can do later. So, always wear personal protective equipment when working with caustic soda and know exactly what to do if you or a coworker is exposed. Guidelines for unloading caustic soda. The following information on unloading is designed to emphasize major topics for consideration. It is the responsibility of facility personnel to ensure they thoroughly understand the hazards of caustic soda solution and have developed appropriate work procedures to manage caustic soda solution safely in their facility. Caustic soda is typically transported as a 50% solution in stainless steel or lined tank trucks, or insulated and lined rail cars. When unloading caustic soda, general guidelines should always be observed. Also follow all appropriate federal, state, provincial, or local regulations throughout the procedure. To begin, safe unloading can be accomplished by following carefully planned procedures. All personnel involved in the unloading of caustic soda should complete proper training and wear proper protective equipment. Always unload rail cars and tank trucks over a designated spill containment area. Unloading should take place during daylight hours whenever possible. If unloading is to take place at night, make sure proper lighting is present. Check all safety equipment before working with caustic soda. Showers and eye wash stations should be checked for adequate water flow and temperature. Make sure showers and eye wash fountains are conveniently located, clearly marked, and easily accessible. Preferably, safety showers should be located directly above the eye wash stations. In most cases, when a safety shower or eye wash station is activated, an alarm will sound to summon assistance. If this is not the case at your facility, consider having an alarm installed. Note that self-draining and tempered safety shower water systems and heated eye wash stations may be required in freezing conditions. The next step is to spot and level the tank truck or rail car, set the brakes, and chalk the wheels. Before connecting unloading equipment, confirm that proper lines are present and dedicated to a caustic soda storage tank. Make sure the storage tank is properly vented and the vent line is open and clear. And check that the storage tank has sufficient capacity to receive the entire contents of the tank truck or rail car. Consider leaving at least 10% of the storage tank empty to ensure adequate space for expansion. Partially unloaded tank trucks and rail cars should be moved with extreme caution. Due to the high density of caustic soda, a partially filled vessel may be unstable during transport. You are now ready to unload caustic soda. Additional modules in this DVD address specific issues associated with unloading a rail car compared to unloading a tank truck. Thawing caustic soda in rail cars and tank trucks. The following information on unloading is designed to emphasize major topics for consideration. It is the responsibility of facility personnel to ensure they thoroughly understand the hazards of caustic soda solution and have developed appropriate work procedures to manage caustic soda solution safely in their facility. Only experienced, thoroughly trained personnel wearing proper protective equipment should be involved in any unloading operation, including thawing and heating. Safety and eye wash showers should be readily accessible and in proper working order. See Module 3 for additional details. Rail cars and tank trucks in Dow caustic soda solution service are insulated to help prevent freezing. Furthermore, the viscosity of caustic soda solution increases rapidly as its temperature falls. Before beginning, the vessel must be vented to avoid pressure buildup. open the manway cover or the vent valve on the top of the car. Use caution when opening the vent valve. Open it slowly and stand away from the outlet to avoid any possible discharge. Always check the solution temperature before unloading. Even if the air temperature feels warm enough, transit delays in a cold environment may have lowered the temperature of caustic soda. Generally, if the temperature of the caustic solution is above 85 degrees Fahrenheit or 29 degrees Celsius, it can be unloaded without steaming. If it is below 65 degrees Fahrenheit or 18 degrees Celsius, steaming is usually necessary. If the temperature is between these two extremes, it's still a good idea to heat the rail car or tank truck to reduce the solution's viscosity for easier unloading. Often, it isn't necessary to heat the entire contents of the rail car or tank truck because it is only the caustic soda around the outlet valve that has frozen and is causing a blockage. First, steam the area around the outlet valve with a steam lance. This is particularly true when unloading from the bottom. If the caustic soda is still frozen, further heating may be required. Rail cars used to ship Dow caustic soda are equipped with steam coils, which allow the safe heating of the solution. Tank trucks are not equipped with steam coils. When using a steam lance to warm caustic soda, regulate the steam supply to 15 pound-force per square inch gauge, or 103 kilopascals or less to prevent damage to the car lining. A steam trap should also be installed on the outlet steam coil to maximize heating efficiencies. Never let the caustic soda solution exceed the maximum temperature of 150 degrees Fahrenheit to avoid damage to the protective lining. Once the caustic soda is completely thawed, it is ready for sampling and unloading. Shut off and disconnect steam lines before starting the unloading procedure. Do not continue to steam once unloading has started, as additional heat will damage the rail car lining after the caustic soda level has dropped below the coils. In extremely cold temperatures, it may also be necessary to preheat the unloading lines to prevent them from plugging. This can be done with a maximum of 15 pound-force per square inch gauge or 103 kilopascals steam tracing or by electrical heat tracing. Either way, the unloading line should be well insulated. When checking the unloading lines, all horizontal portions should freely drain toward the storage tank. This will ensure this portion of the unloading line is empty, except when unloading. You can now proceed to unloading the caustic soda as described in the following modules. Note: assure that all steam lines that have been used have been disconnected. Unloading tank trucks. The following information on unloading is designed to emphasize major topics for consideration. It is the responsibility of facility personnel to ensure they thoroughly understand the hazards of caustic soda solution and have developed appropriate work procedures to manage caustic soda solution safely in their facility. Only experienced, thoroughly trained personnel wearing protective equipment should be involved in any unloading operation. Your operator must comply with all of your company's safety procedures. It is recommended that a checklist be used for caustic soda unloading operations. A sample checklist is found in Chlorine Institute pamphlet number 87. Prior to beginning the unloading process, be sure the storage tank vent is clear and the tank has enough volume to hold the contents of the tank truck. When unloading caustic soda from a tank truck, your operator is usually responsible for most of the details. Sometimes the driver offloads the truck. Typically, the driver-operator will require only a 2-inch male connector on your permanent system. Ultimately, it is your responsibility to sign off that the driver has properly attached the unloading hose to the proper tank. And it is also your responsibility that the tank has adequate empty space to hold the entire contents of the tank truck. It may be necessary to heat the bottom outlet valve and the caustic soda solution so it will flow easily, especially in cold conditions. Heating coils are not present on tank trucks. This procedure is explained in Module 6. Before the tank truck can be connected for unloading, it should be spotted above a spill containment area and lined up with unloading equipment. Once the tank truck has been spotted, set the handbrake and chalk the wheels. The bill of lading along with other modes of verification, should be reviewed to ensure that the shipment contains caustic soda. Break the tamper-evident cap seal over the unloading piping. Unless the tank truck's compressor is being used for offloading, turn the engine off and take the keys from the driver to ensure that the tank truck will not be moved prematurely. Rope off or set up barricades to keep traffic out of the unloading area. There are two primary ways to unload caustic soda from tank trucks: air pressure and pump. When the tank truck is equipped with an induction pipe, it can be unloaded from the top. Otherwise, most tank trucks are bottom unload. Unloading tank truck via air pressure. Connect the flexible unloading hose to both the unload pipe and the storage tank transfer line. Using proper safety equipment, check the dome cover. It must be closed and securely fastened. Leave the dome cover closed unless a retain sample is needed. If a retain sample was collected, make sure to close the cover. Make sure the gasket is properly and securely in place, and the dome latches are securely fastened. If the tank truck is not equipped with an air compressor, you may have to install a prefabricated air supply assembly that includes a regulator to control the pressure, a check valve to prevent contamination of the air supply, a safety valve to prevent overpressuring the tank, a block valve to isolate the air supply, a bleed valve to vent pressure, and a pressure gauge to monitor air pressure. If a tank truck is equipped with an air supply that is connected, it is ready to operate. Connect the air supply line to the air inlet valve located on the top of the tank truck. To pressurize the tank truck, open the air supply valve. The typical air pressure is 30 psi. To start the transfer of caustic soda to the storage tank, slowly and carefully open the unloading outlet valve until there is suitable flow of caustic soda to the storage tank. Make an inspection of all connections for possible leaks. If a leak is found, close the unloading outlet valve and stop the flow of pressurized air to the tank truck. Relieve the air pressure to the tank truck through the air inlet connection. Eliminate sources of leaks with proper tightening or replacement of piping or fittings. Apply air pressure and open the unloading outlet valve as described earlier to continue the transfer of caustic soda. During product transfer, periodic air pressure adjustments may be necessary in order to complete the transfer and empty the truck. The sound of rushing air or a drop in pressure will indicate that the car is empty. Once the tank is empty and the unloading line is completely drained, shut off the air supply and let it stand for a few minutes to relieve all internal pressure in the tank. Close the air inlet valve and depressurize the air inlet line. Then, disconnect the air supply line fittings from the air inlet on the dome. Close the unloading outlet valve. When unloading is complete, make sure there is a water source available for washing and cleaning. Now, disconnect the unloading hose and replace the cap tightly. Purge the unloading hose and wash down the area with plenty of water. Tank trucks can also be unloaded from the bottom using a pump. First, remove the tamper-evident dome cover seal and open the dome. Then, secure the dome in a partially open position. This diagram illustrates proper bottom pump unloading. At the rear of the tank truck, break the cap seal and remove the unloading pipe cap. Connect one end of the flexible unloading hose to the unloading pipe and the other end to the pump. Using the hydraulic hand pump, open the internal unloading valve. Then, open the external unloading valve. Start the pump. Check for leaks and tighten fittings as necessary. When the tank truck is empty, shut off the pump and purge the system. Close the internal valve, and then close the external valve. The loss of pump discharge pressure will typically indicate the tank truck is empty. Remove the unloading hose. Wash the hose and hose gaskets thoroughly. Replace the unloading pipe cap. Whichever method is used, when unloading is complete, make sure you have a water source available so the driver or your operator can wash out and dilute any caustic soda remaining in the unloading hose and wash off any minor spillage on the tank truck or ground. Collection facilities should be available to handle spills and washout streams. By carefully following proper unloading procedures, another tank truck of caustic soda is safely unloaded. Unloading rail cars by pumping from the bottom. The following information on unloading is designed to emphasize major topics for consideration. It is the responsibility of facility personnel to ensure they thoroughly understand the hazards of caustic soda solution and have developed appropriate work procedures to manage caustic soda solution safely in their facility. Only experienced, thoroughly trained personnel wearing proper protective equipment should be involved in any unloading operation. It is recommended that a checklist be used for caustic soda unloading operations. A sample checklist is found in Chlorine Institute pamphlet number 87. Prior to beginning the unloading process, be sure the storage tank vent is clear and the tank has enough volume to hold the contents of the rail car. Before unloading can begin, it may be necessary to heat the bottom outlet valve and the caustic soda solution so it will flow easily, especially in cold conditions. This procedure is explained in Module 6. Unloading should take place over a spill containment area. Once the rail car has been spotted, set the handbrake and chalk the wheels. The bill of lading, along with other documents of verification, should be reviewed to ensure that the shipment contains caustic soda. Place a rail car connected sign on the rail car. Put a derail and a caution sign at the open end or ends of the siding at least 1 car length away. The use of a stop block can be used as an alternate method of isolating a rail car. Now the rail car can be unloaded. Put the portable handrail or halo in place as a safety precaution against falling. Check and remove the bulk product tag. The next few steps involve the loading valves. While at the top of the rail car, remove the multi-valve housing cover locking pin seal and open the covering on the air inlet and induction pipe valves. Make sure there is no pressure in the rail car by slowly opening the air inlet valve. Make sure the valve is in the closed position, then carefully remove the cap and open the air inlet valve to vent the rail car. When the pressure is relieved, it will be safe to open the manway cover. After collecting a retain sample, if needed, the next step is to prop the manway partially open. This prevents collapsing the rail car when unloading by pump. It also allows for thermal expansion while heating the material. When the caustic soda is at the proper temperature for unloading, ensure the bottom valve is closed and carefully remove the plug from the outlet valve underneath the rail car. Install the unloading assembly underneath the rail car. Next, close the bleed valve on the prefabricated unloading assembly. Attach the flexible unloading hose to the rail car. Verify that the bleed valve at the pump is closed. Open the discharge valve on the pump. Return to the rail car. At the bottom, open the outlet valve. At the top of the rail car, open the internal block valve and check to make sure the manway cover is secured in a partially open position. Return to the bottom of the rail car and check for leaks. Start the pump. Make an inspection of all connections for possible leaks. If a leak is found, shut off the pump and close the valves and stop the flow of caustic. Eliminate sources of leaks with proper tightening or replacement of piping or fittings. Reopen valves and start the pump. Once the rail car is unloaded, shut off the pump and close the internal block valve. When finished, fully open the manway cover and visually inspect the rail car to confirm it is empty. The residue caustic soda solution should form a liquid heel of no more than 1 foot wide in the bottom of the rail car. If a light is used for the inspection, it should be explosion-proof rated due to a possibility of an explosive mixture of hydrogen and oxygen in the rail car. Ideally, use DC-powered lighting. Attach a rope to the light to prevent it from falling into the rail car. Once you have verified the rail car is empty, clear and disconnect the unloading hose. Close all valves and replace all fittings and coverings on the car. When closing the dome lid, make sure the gasket is properly and securely in place and the dome latches are securely fastened. Reseal the car with the return seals provided. Clean the unloading hose and wash down the rail car and the containment area with plenty of water. Collection facilities should be available to handle spills and washdown streams. To begin return preparation, if steam lines have not already been removed, disconnect them and blow out the heating coils with compressed air. Remove the portable handrail or halo and any tools that may have been left in the area. Assure all placards are in place and legible. Remove the wheel chocks and inspect the area around the rail car. Finally, remove the derailleur or stop block and the rail car connected signs. The rail car can now return to Dow. Prepare the rail car for return by following Dow's routing directions. If these directions have not been released, contact your Dow representative for specific instructions. Unloading rail cars via air pressure. The following information on unloading is designed to emphasize major topics for consideration. It's the responsibility of facility personnel to ensure they thoroughly understand the hazards of caustic soda solution and have developed appropriate work procedures to manage caustic soda solution safely in their facility. Only experienced, thoroughly trained personnel wearing proper protective equipment should be involved in any unloading operation. It is recommended that a checklist be used for caustic soda unloading operations. A sample checklist is found in Chlorine Institute pamphlet number 87. Prior to beginning the unloading process, be sure the storage tank vent is clear and the tank has enough volume to hold the contents of the rail car. Before unloading can begin, it may be necessary to heat the caustic soda solution so it will flow easily, especially in cold conditions. This procedure is explained in Module 6. Unloading should take place over a spill containment area. All rail cars are equipped with an induction pipe and can be unloaded from the top using air pressure. Once the rail car has been spotted, set the handbrake and chalk the wheels. The bill of lading, along with other documents of verification, should be reviewed to ensure that the shipment contains caustic soda. Put a derail and a caution sign at the open end or ends of the siding, at least 1 car length away. Place a rail car connected sign ahead of the derail. The use of a stop block can be used as an alternate method of isolating a rail car. The rail car is now ready to be unloaded. From the unloading platform, lower the drawbridge to the top of the rail car. Extend the safety railings. Place a portable handrail across the opening in the dome safety rail. Check and remove the bulk product tag. The next few steps involve the loading valves. Remove the multi-valve housing cover locking pin seal and open the covering pin on the air inlet and induction pipe valves on the top of the rail car. Make sure there is no pressure in the rail car by using the air inlet valve. Verify that the vent valve on the rail car is tightly closed. Then, carefully remove its cap. Connect your Christmas tree assembly to the rail car vent valve. After collecting a retain sample, if needed, ensure that the manway cover is securely closed. When closing the manway cover, make sure the gasket is properly and securely in place and the dome latches are securely fastened. Connect the flexible unloading hose to both the induction pipe and the storage tank transfer line. If the rail car is not equipped with an air compressor, a prefabricated air supply assembly, commonly referred to as a Christmas tree, must be available. That includes a regulator to control the pressure, a check valve to prevent contamination of the air supply, a safety valve, also called the release valve, to prevent overpressuring the tank, a block valve to isolate the air supply, a bleed valve to vent pressure, and a pressure gauge to monitor air pressure. Connect the air supply line to the air inlet valve located on top of the rail car. To pressurize the rail car, open the air supply valve. The typical air pressure is 30 pounds per square inch. To start the transfer of caustic soda to the storage tank, slowly and carefully open the induction pipe outlet valve until there is a suitable flow of caustic soda to the storage tank. Make an inspection of all connections for possible leaks. If a leak is found, close the induction pipe outlet valve and stop the flow of pressurized air to the car. Relieve the air pressure to the car through the air inlet connection as described earlier. Eliminate sources of leaks with proper tightening or replacement of piping or fittings. Apply air pressure and open the induction pipe outlet valve as described earlier to continue transfer. During transfer, periodic air pressure adjustments may be necessary in order to complete the transfer and empty the railcar. When the railcar is empty and after the unloading line is completely drained, shut off the air supply and let stand for a few minutes to relieve all internal pressure on the car. The sound of rushing air or a drop in pressure will indicate that the car is empty. Close the air inlet valve and depressurize the air inlet line. Then, disconnect the air supply line fittings from the air inlet on the dome. Close the induction pipe outlet valve. Make sure there is a water source available for washing and cleaning. If it is part of your procedures, visually confirm that the railcar is empty. Facing away from the vent valve, open it to equalize the internal pressure. The residue caustic soda solution should form a liquid heel of no more than 1 foot wide. If a light is used for the inspection, it should be rated explosion-proof due to a possibility of an explosive mixture of hydrogen and oxygen in the railcar. Ideally, use DC-powered lighting. Attach a rope to the light to prevent it from falling into the railcar. Now, disconnect the unloading hose and replace all fittings and coverings on the railcar. When closing the dome lid, make sure the gasket is properly and securely in place and the dome latches are securely fastened. Reseal the railcar with the return seals provided. Clean the unloading hose and wash down the railcar and the containment area with plenty of water. Collection facilities should be available to handle spills and washout streams. To begin return preparation, if steam lines have not already been removed, disconnect them and blow out the heating coils with compressed air. Remove any tools that may have been left in the area. Remove the portable handrail or halo if you use one as part of your process. Retract the safety railings and raise and secure the drawbridge. Assure all placards are in place and legible. Remove the wheel chocks and inspect the area around the railcar. Finally, remove the derailleur or stop blocks and the railcar connected signs. The railcar can now return to Dow. Prepare the railcar for return by following Dow's routing directions. If these directions have not been released, contact your Dow representative for specific instructions. Unloading railcars by air pressure from the bottom. The following information on unloading is designed to emphasize major topics for consideration. It is the responsibility of facility personnel to ensure they thoroughly understand the hazards of caustic soda solution and have developed appropriate work procedures to manage caustic soda solution safely in their facility. Only experienced, thoroughly trained personnel wearing proper protective equipment should be involved in any unloading operation. It is recommended that a checklist be used for caustic soda unloading operations. A sample checklist is found in Chlorine Institute pamphlet number 87. Prior to beginning the unloading process, be sure the storage tank vent is clear and the tank has enough volume to hold the contents of the railcar. Before unloading can begin, it may be necessary to heat the bottom outlet valve and the caustic soda solution so it will flow easily, especially in cold conditions. This procedure is explained in Module 6. Unloading should take place over a spill containment area. Once the railcar has been spotted, set the handbrake and chalk the wheels. The bill of lading, along with other documents of verification, should be reviewed to ensure that the shipment contains caustic soda. Put a derail and a caution sign at the open end or ends of the siding at least 1 car length away. Place a railcar connected sign ahead of the derail. The use of a stop block can be used as an alternate method of isolating a railcar. The rail car is now ready to be unloaded. Put the portable handrail or halo in place as a safety precaution against falling. Check and remove the bulk product tag. To begin the unloading procedure, remove the multi-valve housing cover locking pin seal and open the covering on the air inlet and eduction pipe valves on the top of the rail car. Verify the valve is tightly closed. Make sure there is no pressure in the rail car by using the air inlet valve. Leave the manway cover closed unless a retain sample is needed. Once the retain sample is collected, close the cover. Make sure the gasket is properly and securely in place and the manway latches are securely fastened. Carefully remove the plug from the external outlet valve. It may be necessary to use a second backup wrench to prevent the external bottom outlet valve from turning while removing the plug from the valve. Connect the unloading line to the external bottom outlet valve. When secure, open the external bottom outlet valve. Before proceeding, check the manway cover to make sure it is fastened securely. Since the rail car is not equipped with an air compressor, a prefabricated air supply assembly, commonly referred to as a Christmas tree, must be available that includes a regulator to control the pressure, a check valve to prevent contamination of the air supply, a safety valve to prevent overpressuring the tank, a block valve to isolate the air supply, a bleed valve to vent pressure, and a pressure gauge to monitor air pressure. Connect the air supply line to the air inlet valve located at the top of the rail car. Open the air inlet valve and apply air pressure to the car slowly. Typically, about 30 pounds per square inch is sufficient. After securing the unloading line, open the internal bottom outlet valve by turning the valve rod handle. If the outlet valve handle does not turn with moderate pressure, some frozen caustic soda may remain in the bottom of the car, and further thawing may be necessary. Never force the handle. Visually inspect the system for leaks. If a leak is detected, close the internal and external bottom outlet valves and stop the flow of pressurized air to the car immediately to relieve air pressure. Correct all air or caustic soda leaks by tightening or replacing the leaking piping or fittings. To continue unloading, apply air pressure to the car slowly. Open the external bottom outlet valve, followed by the internal bottom outlet valve until there is suitable flow of caustic soda to the storage tank. During transfer, periodic air pressure adjustments may be necessary in order to complete the transfer and empty the car. If you detect a drop in pressure or hear the sound of rushing air, the rail car is empty. When the unloading line is completely drained, shut off the air supply valve and allow the system to stand for a few minutes to relieve all internal pressure in the car. Allow the discharge pipe to drain completely. Close the air inlet valve on the car. Then, depressurize the air inlet line and disconnect the air supply line fittings from the air inlet on the manway. When finished, open the vent valve away from your face to equalize the internal pressure and visually inspect the rail car to confirm it is empty. The residue solution should form a liquid heel of no more than 1 foot wide. If a light is used for the inspection, it should be explosion-proof rated due to a possibility of an explosive mixture of hydrogen and oxygen in the rail car. Ideally, use DC-powered lighting. Attach a rope to the light to prevent it from falling into the rail car. Once you have verified the rail car is empty, clear and disconnect the unloading hose, close all valves, and replace all fittings and coverings on the car. When closing the manway lid, make sure the gasket is properly and securely in place and the manway latches are securely fastened. Clean out the unloading hose with steam or water inside containment areas and wash down the area and rail car with plenty of water. Collection facilities should be provided to handle spills and washout streams. To begin return preparation, if steam lines have not already been removed, disconnect them and blow out the heating coils with compressed air. Remove the portable handrail or halo and any tools that may have been left in the area. Assure all placards are in place and legible. Remove the wheel chocks and inspect the area around the car. Finally, remove the derailleur or stop block and the rail car connected signs. The rail car can now return to Dow. Prepare the rail car for return by following Dow's routing directions. If these directions have not been released, contact your Dow representative for specific instructions. Spill cleanup. Even with the best preventive safety measures in place, accidents and spills can still happen when handling caustic soda. That's why it's important that before working with caustic soda, you be familiar with the material safety data sheet, review all relevant safety precautions, and wear the proper personal protective equipment. Cleaning up small spills in contained areas. A small caustic soda spill in a small area can be cleaned up relatively easily. First, carefully dilute the spill with lukewarm water. Neutralize any remaining caustic soda with weak acetic acid if necessary. Then, vacuum up the spill with equipment that is compatible with caustic soda for reuse or proper disposal. Cleaning up large spills in contained areas. A larger spill in a contained area is cleaned up in a similar manner. But first, try to transfer as much of the spilled material as possible into labeled containers for reuse or proper disposal. Once the size of the spill has been minimized, follow the same procedures used in the cleaning up of a small spill. Cleaning up spills in uncontained areas. A spill in an uncontained area, such as one on soil or gravel, requires additional measures. First, contain the spill and vacuum up as much of the caustic soda as possible for reuse or disposal. Be sure the containers are properly labeled. The contaminated ground material must then be dug up and disposed of according to appropriate regulations. For assistance in handling caustic soda spills, contact the nearest Dow facility. There is also an emergency response number printed on the bill of lading. A Dow emergency response team, made up of specially equipped and trained personnel, is available to assist you with in-plant emergencies. In any spill situation, always consult federal, state, provincial, and local regulations governing disposal. Never discharge waste directly into sewers or streams. Aside from creating a safety hazard, releases of caustic soda may trigger reporting requirements to federal, state, provincial, and local authorities. In the United States, spills must be reported to the National Response Center, and the company must comply with all federal reporting requirements under CERCLA and SARA regulations. The U.S. Coast Guard may also need to be notified under the Clean Water Act. In Canada, federal and provincial laws require immediate reporting of certain caustic soda spills. Users and handlers of caustic soda must know and comply with these requirements. In the event of a transportation emergency outside of the plant involving caustic soda in the United States, call Chemtrec. In Canada, call Canutech. Knowing how to respond rapidly and effectively to a spill situation is an important component of any facility safety plan.